This is a solution video to question 10 of paper 2 from the TMUA 2020 exam. So in this question, we're given real numbers a, b, c, and d, and we're told they satisfy two conditions. The first one is that a plus b is bigger than 0 and c plus d is bigger than a plus b. And the second one is that a plus c is bigger than 0 and b plus d is bigger than a plus c. And then we're told which of the following inequalities must hold given these two hold. So the first one is a is less than d, b is less than c, and the third one is whether the sum of a plus b plus c plus d is positive. And we're given a bunch of options corresponding to which ones are true. So let's first try and think about each condition separately. So let's try and think about condition 1. Okay, so we want to isolate a and d here. So if we look at our conditions, it's helpful to note that there is some symmetry between condition 1 and condition 2. In particular, the relation between condition 1 and condition 2 is that we've simply swapped the roles of b and c from 1 to 2. So we swap b and c, and then we get condition 2 here. So the reason why this is useful is to know that, therefore, if I add this to this and this to this, then I'll sort of restore this, restore complete symmetry in the conditions. So if I do that, then, so if I add inequality 1 to inequality 2, then I'll get 0, because 0 plus 0 is 0. Then I get a plus b plus a plus c, so a plus b plus a plus c. And then I add with c plus d to b plus d. And that's what I got here. And then this is exactly what I mean. What we got now is symmetry, because this term here has both a b and a c, and this term here also has a b and a c. So now this inequality is symmetric in b and c. So if I swap b and c in this inequality, I get the same thing. So anyway, so if we simplify this now, we're going to get 2a plus b plus c, so 1a from here, 1a from here, b and c from here, so 2a plus b plus c is less than 2d, so 1d from here and 1d from here, plus b plus c again, b plus c here. So the b plus c cancels out, so we're just left with 2a is less than 2d and a is less than d. So this is precisely what condition 1 says, so that means that condition 1 is true. So now if we try and think about condition 2, well, if we try to get to this result again using a similar argument, well, it wouldn't work, because conditions 1 and condition 2 are already symmetric in a and d. So if I swap a and d here, there is no change in the inequalities. So we might want to look for a counterexample here. So that we might want to try and think about this is which number matters the most here. So if we think about the value of d, for example, if we set it very large and a to be very small, because a and d are not switching in both inequalities, then if we choose b and c to be small as well, then the roles of b and c don't really play a role, right? So if d and a are very far apart, then c and b don't play much of a role. So what we want is we want to pick a d that's much bigger than a, and b and c such that b and c is much less than d, so that they don't really matter. So if we look at a particular example of this, so for example, a equals 1, d equals 100, b equals 2, and c equals 1, then we can check that both 1 and 2 are satisfied. So 1 just gives me a plus b, so that's 1 plus 2, and we want that to be less than c plus d, so that's 1 plus 100, and that is a true statement. And then if we check inequality 2, the same thing again, so a plus c this time, so that's 1 plus 1, and we want d plus b here, so that's 100 plus 2, and this inequality is true here. So if I pick these numbers, then these two things are true, but b is not less than c, because we chose b to be 2 and c to be 1. So that means that this is a valid counterexample, so 2 does not need to be true. Finally, if we try and look at the last condition now, well, we want to show that we want to either show or disprove that a plus b plus c plus d is positive. Well, if you look at inequality 1 is already telling us that a plus b is positive. But we know that C plus D is bigger than A plus B. So that means that C plus D is also bigger than 0 because A plus B is. So we know that A plus B is positive and C plus D is positive. So that means that A plus B plus C plus D, which is A plus B plus C plus D, must also be positive because that's the sum of two positive numbers. So A plus B is positive, C plus D is positive. That means the sum of the two is also positive. So that means 3 is true. That means our answer must be F.